welcome. Thanks for joining this workshop. Full house, I see. That's great. Yeah, we're going to talk about interesting topic today: deploying generative AI models. So on stage in front of you, I'm Victor. I'm the founder and CTO of UbiOps, and also joining me on stage and is going to do most of the tech talk and the demo is Anouk. She's our head of product, and yeah, we'll be hosting the next 1 hour for you to talk you through developments in GenAI and also try to make it tangible what it means to deploy a GenAI model and control over it in your own environment and integrate it with your own products and applications. All right, so let's start with a few questions to set the scene. So who's used GenAI before? That includes OpenAI, everything.
ChatGPT, those kind of things.
Yeah, pretty much everyone. All right, so who actually worked on deploying GenAI capabilities at your own company or yourself on your own laptop? All right, see a few hands. A lot fewer than the ones who used to work with it, but yeah, it's of course right now a big theme. Like, okay, how are we gonna deploy these kinds of exciting new models? Because they also bring some challenges with them. And first, to set the scene a bit for what we're gonna talk about in the next hour. I'll do a quick intro on like MLOps and GenAI and what's happening in the space right now, and I'll give the floor to Anouk, and she's gonna actually show all of you how to deploy Stable Diffusion.
Yep.
And Stable Diffusion, for the ones who don't know it, it's the model that, based on an input prompt, based on a bit of text, generates an image for you. So it's really exciting for content generation and really state of the art and new. And we're gonna combine it with showing how you do that on our UbiOps platform and how you can how that makes it easy to leverage those capabilities and technologies yourself for your own products and services and your own organization. All right, let's start with quick intro on what we're talking about here today. So currently, of course, as you know, there's a strong growth in AI adoption, and especially now LLMs and GenAI and more like off-the-shelf models become available. There are many organizations and businesses, maybe like yourself, who are looking to how can we integrate these machine learning and AI capabilities into products and services. Like developing a model is one thing, but actually deploying it and turning it into an actual product, that's what's exciting, and that's also what's going to solve problems now and in the future. So over the past 2 years, kind of this whole space of how do I actually manage models in production, how do I operate them, manage them, monitor them, we got to know that as like machine learning operations or MLOps. Calling this MLOps 1.0 as it's more focused on like the traditional machine learning, as in there's a business case, we have a data science team, we have the data, and we're going to figure out kind of what's the best model and what's the best set of features and what's the best approach to use to solve this business case. And once we have that, we have a focused model for one specific business case, and now we need to deploy it. So there's a deployment, and there's inferencing and serving of the model, and also how do you want to scale it. And that whole life cycle is what we know as machine learning operations, and also includes monitoring and observability. And if you know kind of how the model is performing, you also know when to retrain it, and it becomes a nice life cycle that you can integrate with your existing software development processes and capabilities in-house. So that's the more like traditional approach. Now, right now, as like since last year, basically, we suddenly have access to very powerful pre-trained models like Stable Diffusion, like different LLMs, large language models like Llama and Falcon that give you these really powerful capabilities out of the box. So you can take this model off the shelf, get it from like a model hub, like Hugging Face, and basically run it, and suddenly you have a chatbot, and suddenly you have something that generates content for you, and suddenly you have an image generator, and it provides so much capabilities out of the box that you can actually basically skip this whole step of doing the experimentation and data pre-processing, feature engineering, because these models are so powerful and large that you can basically implement them without touching them. But they also come with some additional challenges. So we see that suddenly we have this term called large language model operations, or kind of foundation model operations, like more broadly, for like taking an off-the-shelf model, fine-tuning it, doing prompt engineering, and deploying that while actually skipping most of the steps that we usually spend most of our time on, like where data science teams spend most of their time on. So still we need to care about data management and versioning, but the step of getting to a working model is suddenly a lot easier. But these two things, they do come together as we talk about more like production and serving and inferencing of those models. So kind of these new LLM and foundation models will coexist with the traditional machine learning things that we used to develop in the past few years. And yeah, that's also why actually inferencing and serving of machine learning is such an interesting thing to look at right now, because that's eventually what's going to give AI products and AI services the kind of robustness and stability we need to actually make them operational systems that we use in our daily lives. And if you zoom in on what it's like to deploy an AI model, actually the machine learning model itself is already it's already there. It's maybe developed by data science team or off the shelf, as we're just discussing. But suddenly, if you have to turn it into a robust, scalable system, there are a lot more different bits and pieces that you have to think about before you actually have a working, like, enterprise-grade app or service. So need to think about, a bit of model management, version control, especially you have multiple models that you're governing in your organization. You have to keep track, kind of keep an administration of what type of models you have, version control them, but also especially take care of how they scale and where they run, right? Like that's the core thing. I want to have a machine learning model, but I also want to have a server and basically run the model on that server and make sure it processes data all day. And if the data, if the traffic increases, you also want to know that the model actually scales up and is able to process more requests and more data at the same time. And that's exactly kind of the difficulties that most data science and AI teams struggle with, and most businesses struggle with, to get an infrastructure that actually supports all this stuff out of the box without spending too many hours on engineering, reinventing the wheel, and building all these things yourself. Because it's also not your core IP or not your core capabilities to focus on that, because you want to focus on the model and solving this business case. Right, so as UbiOps, we focus on a space that's called more like model ops and MLOps, so kind of sit between the data science code and the pre-trained models and your like cloud infrastructure. Now for, you can skip to the next. So we focus on providing you with an AI infrastructure for serving and hosting machine learning models of all different shapes and sizes, and make sure they run scalably in the cloud or across hybrid or multi-cloud environments, and give you an easy interface to basically turn these machine learning models into scalable prediction endpoints and inference endpoints, and also chain different models together, where you get nice pipelines and build modular applications. And especially for generative AI, and I'm not sure who was at the talk yesterday about kind of the challenges for deploying generative AI models, is they require more GPU capacity, so it's more difficult to deploy them, and it's also more costly. And actually, because of the challenges and demanding nature of this very large models, we need to have a more flexible approach to where they run and where we actually do this compute. So we're also trying to integrate like a multi and hybrid cloud approach to serving different AI workloads and training jobs. And also make sure that they scale right. So I was saying, if you're looking at a production grade AI system and machine learning system, you actually want the models to scale with the traffic and have some load balancing involved there. But also, especially for large models that occupy GPUs, don't have them occupy GPU all day if they're not doing anything, because that's just getting really expensive over time. So you want to on and offload models on the fly based on incoming traffic, based on incoming data points. And when you do that, you suddenly follow more the kind of natural demand curve of incoming traffic instead of occupying space in your compute clusters all the time for every model that you want to run. So that's what we focus on too. So really about the deployment and serving, but also deeper into the stack for like, how do I orchestrate this efficiently across different compute environments, and how do I on and offload models on the fly as we go and manage that from one single interface. All right. So zooming in on what we're going to do today and a bit what's happening, it's like what we see as a, let's say, best practice approach to deploying machine learning models, but also deploying generative AI models, is you want to always end up with a robust, reliable system. So you want to start with kind of containerizing the code that you deploy and run it as a microservice. So you want to kind of pin the dependencies of the model and the code that you run in a container and kind of fix that and kind of keep that fixed, because it's so you ensure that it's always working in the same way. And as a next step, want to run these containers depending on where compute is available. Could be on-premise, could be in the cloud or across different clouds. So we take the containers and we push them to the different compute locations, while in the meantime managing the incoming data traffic. And for each of these models that's running, provide you a scalable prediction endpoint. So you get one endpoint where you can send data to, and it's going to process it. And if traffic is increasing and the queue is filling up, it starts another instance of this same container, of which you know that it's exactly the same as the one you used before, and it starts scaling horizontally and processing the traffic at the same time. And on top of that, we're adding authentication and security, like user management and more MLOps features about who can touch which models. We have version control in there as well. And as an important part, also monitoring and logging. Like for production systems, you want to kind of know what's going on. So we also collecting metrics and information from the models about how they run, how much compute they consume, if everything's going right, and if there are any errors or failures with the processing all that data. And zooming in today more on the GenAI stuff, one of the challenges is to take these larger models and deploy them, because they don't run on just standard CPU nodes anymore, which are available everywhere. But they actually need to run on like GPUs mostly. And GPUs come in different shapes and sizes as well. And especially the very large models need to run on data center grade GPUs, which people don't have in their laptops anymore. And that's also why we look at diversifying where you buy these GPUs and where you can actually still access them and get them, because they're so expensive and also unavailable right now in most of the cloud regions, that you have to kind of diversify your approach of where you actually find your compute. And I'm about to hand it over to Anouk. This is kind of a nice bridge to what we're going to do, I think. So we're going to take GenAI model, like Stable Diffusion, and most GenAI models have a similar structure. So they give a text prompt as input. So as a user, you kind of ask a question to like ChatGPT, or you ask Stable Diffusion to draw a picture of something. And what we're focusing on today is how do we get this GenAI model to be containerized and deployed in the cloud. So we have an API endpoint where we can send those prompts to, and also get the output, which is the generated content, which is a piece of text, or in this case, an image. And yeah, time for the workshop, and yeah, to show some code on the screen. So hand it over to you.
Exactly. Yeah, because of course, Victor just took you through the entire conceptual journey that you would have to go through if you want to deploy generative AI models. But I can imagine that you might still be thinking like, okay, this sounds great, but how does this actually work when I want to do this myself? What steps do I take? So what I'm going to do today is I'm going to live deploy Stable Diffusion to the cloud. So let's pray that the Wi-Fi gods are with me today and that it won't crash. And I also hope that it will provide a little bit of a break from all the maybe policy fluff that you might have been hearing, so showing some actual code today, okay? So let me just dive in, show you what I'm going to do. I just want to preface this by saying that I will be showing a Google Colab that I'm going to use. I'm also going to show a QR code. Just take a picture of it if you want to do this at home yourself later. I wouldn't advise you to do it right now live with me because we've got limited table space. But just know that everything I'm going to show you is going to be available afterwards as well if you want to reproduce what I'm going to do. So what are we actually going to build today? So today we're going to build a live prediction engine basically on UBOps based on Stable Diffusion. You might know Stable Diffusion already. It's a text-to-image model. We're going to use a pre-trained one from Hugging Face. And it's capable of generating really like photorealistic images. And yeah, basically any kind of prompt you put in, we're going to be able to see what kind of images it comes up with. So how this roughly looks when we want to put this on UBOps is something like this. So I'm going to send in a prompt. So in this case, I just took an example of like dragon, hyper-realistic, sitting on a throne. I like dragons, so that's why. We're going to send that to an API endpoint. And that API endpoint is actually going to pass that data to a live Stable Diffusion model that's running on UBOps, so that's running in the cloud. And that model is going to come up with like an image and send that back as output, and that's the output that we can receive. So that's very basically what we're building. So just to know how this works, I want to quickly explain what deployments are in UBOps, because I'm going to show you how to create one. So deployments are objects within UBOps that actually serve your code. So it supports any kind of Python or R code. It doesn't have to be a pre-trained model like I'm going to show today. It can even be something as simple as like a data processing step. And what UBOps will do is that it will turn that piece of code into a scalable microservice that actually has its own API endpoint that we can send data to. So the steps we need to follow for this is that we need to actually write some code for loading that Stable Diffusion model from Hugging Face and sending the data to the model. So I'm going to show you how that looks in a bit. Once we've got that code, we can actually deploy it to UBOps. UBOps will take care of the rest. And then we can use that model API that comes out of it to actually send prompts to it and see what it comes up with. So enough talking, I think. Let's just get started. This is what you need if you want to follow along later or like reproduce what I'm going to do. So you will need a UBOps account. It's completely free. You just need to go to app.ubops.com/signup. And after that, you need the Google Colab that I prepared for you to follow along. The QR code should take you to the Google Colab if you want to produce it at your own leisure as well. Just going to wait a second because I still see some people taking pictures. I think we also have everyone's email addresses so that we can actually send a copy of the slides and the links as well. So don't worry if the image is too blurry because it's too far from the back. We'll make sure that you get the materials. OK, so without further ado, let's get started. So let me start from the UBOps web app. So I'm going to show you a lot of code, but before we get to the code, we need an API token to actually make a connection. So I'm just going to show you how that works. So I need to go to permissions in my project. I don't know what's going on.
I think we need more Wi-Fi.
Yeah, it
first.
looks like the Wi-Fi is a bit.
Yeah.
Let me refresh. Maybe that helps.
Okay, that looks better.
Yeah, okay, we're there. So I'm going to make an API token. This is just to make sure that I can actually call the UBOps API to deploy things. So I'm going to click Add Token. I'm going to give it a name. So let's say World Summit AI token. I'm going to go to the next step. Then I need to tell UBOps what kind of permissions does this token get. I'm just going to give a project editor permission so I can really create new deployments and do everything. Then I've got a token, which I'm going to copy. And now that we've got that, we can go to our Google Colab. So first things first, is this readable for everyone, or should I zoom in? Little bit zoom in? OK. Yeah, a bit better? OK, cool. So let's get started. First things first, we need the UBOps client library, because otherwise we won't be able to do anything. Of course, Google Colab is going to give a remark that Google didn't write this themselves, but I know I wrote it, so I can just say, like, OK, sure, let's execute it. So once we have installed the UBOps client library, we can use that to talk to UBOps. So what I just showed you in the web app, that's my project. I'm basically going to set up a connection to that project to be able to write things to there. So we need to define some information first. So I've got my project name here. If you want to run this notebook yourself, you will need to switch this with your own project name, because, of course, you won't be able to connect to my project. So if we just run this, then it will ask me for an API token. So I'm just going to paste in the one I just copied from the web app and run it. And then we should get back status OK, which indicates that there's now a connection to our API. What you can also see is that I already defined some environment variables for things that I'm going to use a lot in the code. So a name for my deployment, so Stable Diffusion with the date of today, and a deployment version. That's all that's going on here. So now that we've got that, let's start first by setting up the environment we will need for running Stable Diffusion, because Stable Diffusion has some dependencies. So we need to tell UBOps what kind of dependencies it needs, and that it needs to make sure that that's ready in whatever environment we're going to run Stable Diffusion in. So I'm just going to make a directory for all my environment files. And then I'm going to, like with this statement, this cell, the write file, it will just write the contents of this cell to requirements.txt, which contains all the packages that I need to run it, so like the transformers, diffusers, etc. And then, because I want to run it on a GPU, I also need some extra information to get the right PyTorch version that actually supports CUDA. So I'm also making a UBOps YAML. A UBOps YAML is just something that UBOps uses for installing opt-get packages. So anything for like OS level that's no longer from PyPy, we can define like this. So now that we've got that done, we can actually create the environment. Now, I actually already created this environment before, so I can just give it a quick new name, because otherwise it's just going to throw an error. So let's say this is... This is number 2. So I've got that little f string, and now if I'm also going to change this to use the CUDA version. I left it out because with the free version you don't have access to GPUs, but I'm going to use a GPU because it works quite a lot better with a GPU, of course. So that's why I'm going to use the Python 3.9 CUDA version, so that it actually has CUDA installed already. So if I run that, it already existed even with number 2. I'm going to run it again. Then we'll actually start making this environment in the background, getting all the packages ready for us. So when we upload the file, OK, so now we can actually continue to the actual deployment code. Like, how are we going to run, or how are we going to run Stable Diffusion? So to do that, I'm going to make another directory for my deployment code. And then I've got this cell here, which writes the contents of the cell away to something called a deployment.py, and this contains the main instructions. So what UBOps needs to be able to run your code is a class called deployment, within it at least these two functions, an init function and a request function. The init one is that we run whenever we initialize your model, so that's for things that need to be kept into main memory. And the request function is the one that we run whenever new data is being sent to the model. So what you can see here in my code is that I'm first checking if a GPU is actually available, just to know that if one is not or something is wrong, that I can debug that. And I'm loading like a stable diffusion pipeline from a pre-trained model, which I'm just getting here. So that's what this code does. It already loads in the stable diffusion pipeline so that it is ready. And then in the request method, all I'm really doing is putting the data, so the prompt that is coming in, that is being sent to the model, I'm just putting that through that stable diffusion pipeline. Out will come some kind of image, so I'm saving that image as a PNG, and I'm returning that in the output. That's all that's happening here. So if I run that as well, then it will have made that deployment.py, so we've got that now. And now that we've got the code ready, we can now push it to UBOps. So to do that, we need to create a deployment. So first going to make the deployment template, which basically just defines what kind of input and output are we expecting. So in our case, we're expecting an input prompt, which is of data type string. And we're expecting an image being sent back, which is of data type file. That's all what I'm specifying here. And now that we've got that deployment, we can actually make a version. And the version is what contains that code that I just wrote. So I need to tell UBOps what kind of hardware I want to run on. So I actually want to run on a T4. So I'm going to change this to be 16 gigs with T4. We can specify the minimum and maximum number of instances. This is for scaling, like how far can we scale up, and should we scale all the way back down when it's not used, and whether the request should be saved or not. So when I've got that, I can run that, and that will be created. Now that the version is there, we just need to push our code to that. So what I'm doing here is that I'm zipping that little archive I made before with our deployment code, and I'm just pushing that to UBOps. Okay?
Oh, Anu?
Yeah.
Maybe it's nice to show that it's actually visible in the UI too.
Definitely, because it will need to build a little bit. So I'm going to switch to what you can actually see in the UI, that you can see that I actually just did this. So if I go back to the web app, and I go to my deployments, you will see here Stable Diffusion with our current date. So that's the one that I just created. You can also see like it was created a few seconds ago. So if I go to that one, we can actually see what's happening. So it's actually already ready and built. So what we now got is that we have an API endpoint that we can start sending data to. I could do this directly here from the UI, but I'm going to quickly show you how to do it from code as well. Because normally when you would hook it up to the rest of your stack, let's say a website or something, you'll also use the API. Like your website is going to call the API. You won't have someone manually pressing a button in the web app. So let's go back to the Google Colab. OK. So now we can actually create a request to it. So I've got here a green dragon portrait. When I tried this earlier today, this came out, which I was quite happy with. So let's see what it comes up with this time. So we can send that to it. Now, of course, even though I'm using quite a powerful GPU, it's still Stable Diffusion. Stable Diffusion is a big model that takes some time, even on a T4 to run. Ideally, you would want to put it on an A100 if you really want super low latency. Which is also possible. So this can take maybe like 2 minutes before it actually has the result. So in the meantime, let me actually just show what's going on in the background. So when I go back to the web app, now what we can see when we go to the request tab is that you can see here this request that I just made. So we can follow its progress. We can also turn on notifications to be notified when it's finished. But we can also see when we go to the metrics of this model that it's actually started doing something. And we can also follow things through monitoring. So when you go to our monitoring tab, that's where you can see everything that's happening in your project. So we can see that I just made a request that's coming in, what the memory usage is, those kind of things, to be able to tweak my parameters and check if it actually works for the type of model I'm deploying. And everything that's going on in the background is also ending up in the logs. So you can here actually see everything that's going on. And I think it might actually be done. It is done. So then we can check what the result actually was.
That's a lot faster than 2 minutes.
Yeah. So we've got our result. I just downloaded it, so let's just visualize what actually came up. And this is our green dragon portrait of this time. And basically, we now have this API that works. The more data I'm going to send to it, the more it could scale up. Right now, I set my scaling settings to only a maximum of 1, so it cannot scale further than 1 instance. But I did set the minimum number of instances to 0. So when I won't be using this for 5 minutes, it will start scaling back down so that it also is not eating up my valuable resources with that GPU. Does anyone maybe have a suggested prompt that I could do? Maybe you in the front. Do you want something? You've got a prompt. What should I send it?
Blue dolphin.
A blue dolphin. I like that one. Let's see what it comes up with. Okay. Let's see if we can check again that it's... Yeah, there we see. We can already see that it's starting to run that stable diffusion pipeline. What's going on? And it's also nice to see that with our previous request, we were actually using like 99% of the GPU. So we can also see that we were really using all the power that was in there. Because something that tends to happen with data science projects, at least what I see, is that sometimes the code is not optimized to run on a GPU. And you have like this very expensive NVIDIA A100, and you're actually only using like 20% of it. So why are you paying like that premium for such a powerful GPU, and you're not even using the full power of it? Oh, and it's done. So let's see. There we go. There's your blue dolphin. OK, that's everything I actually wanted to show, because we're done. So just want to say a quick thank you for your attention and for following along. Here's our contact details. We also have a booth in the general hall where you can find us is in front of the restaurants. We've got like the fish restaurant. That's where we are. So if you have any questions there, please come find us. And maybe we actually have some time left. So does anyone have any questions right now that they want to ask?
Thank you.
Okay.
We can go back to the code if anything was unclear, or kind of show more of the UI. Any general questions? We have quite some time left, so happy to do a bit of Q&A here. And,
Sorry, what did you say? I think what I heard from you is if you're asking if we do the call asynchronous or synchronously. Yes, we do. I can actually show you how that would be. Indeed, like the request I just made was a direct request, which is synchronous. So we keep the HTTP port open. If we don't want that, like let's say we've got a request that takes longer, like an hour, then you might not want to do that. So how it would work in that case is when we go to the create request option, you've got two options. So what I used just now is called a direct request in UBOps, but we also have the option to create a batch request. And not only does it allow you to input multiple data points at a time as a batch, it also runs asynchronously. So when you send off the data, you only get a response back like, oh, request received, but not with the status, and you will have to poll later to get the actual results of it. And these batch requests can run up to 72 hours in UBOps. Direct requests go up to 1 hour. Does that answer your question? Cool.
Yeah. We actually applied that to support training workloads in UBOps as well, so they can run for a long time and run on any like GPU or kind of powerful hardware. And it's right there, so we added a workflow around it, but it's based on the same concept of deploying code and creating both like synchronous, asynchronous requests to it.
Yeah. Any other questions? Yes. Very good question. So for the ones who didn't hear, the question was, who provides the GPUs that we use and how do you pay for them? So the one I just run on was one on Google Cloud, because what I'm showing you right now is our SaaS version. Our SaaS version runs entirely on Google Cloud. But UBOps is completely cloud and infrastructure agnostic. So actually what I have in my project, which is probably good to show, is I've got a compute environment and two European clouds coupled to my project as well. So what I can do, let's say I don't want to use a T4 from Google Cloud, I can change the instance type, or actually it's not this project, it's the UBOps demo. Let me go there, demo, to show you, because I can change the instance type to be one in a different cloud location as long as it's coupled. We also do fully on-premise installation. So let's say you're running on Azure, we can also install in there. The hybrid setups with the SaaS and just the compute pool is the easiest, but it depends on what your needs are. And for paying, the paying is for the SaaS version, it's on demand. So the more you use it, the more you pay. But for on-premise, you bring the compute. So then, of course, we're not going to charge you for the compute, but it's more the installation and the support around it. Let me show you quickly. So here, I've also got a stable diffusion model. So if I would want to run that in a different location, here's how that would work. So you can see here that some of the instance types here have in between brackets another word. So for instance, here I've got one from Intermox. Intermox is a Dutch cloud provider. And I've also got one from Azure Cloud, which is also a Dutch cloud provider. So if I would want to make sure that it runs in that location, I can just change the instance type, and that's all I would need to do to change the flow. Does that answer your question? Yeah, perfect. Any other questions? No? Okay, well then, thank you very much, and please pass by our booth to talk further.
Well, thank you.